Good morning. Can you believe this is our very last lesson? This is your very last math lesson in third grade. How crazy is that? We've made it to the end. Let's go out with a bang, with gusto here. Okay, let's read the bottom together, please. Construct rectangles with given perimeter using unit squares and determine their areas. Okay, so as you know, we do not have unit squares. So what I just have a piece of paper. You can just use any scrap piece of paper. Use the back side of a paper you already used. But we're gonna work through this together just on scratch paper. Okay? So let's read the first one together. It says, use your unit square tiles, or a piece of paper, to build as many rectangles as you can with a perimeter. I'm gonna underline this. We've been working a lot with area, but today we are working with perimeter of 12 units. So then A says, estimate to draw your rectangles below. Label the side lengths of each rectangle. So we need to find a perimeter. Perimeter. This is going to be more challenging because we're not multiplying side length times side length. So we're gonna have to find 4 side lengths, okay, of 12. So if we start off with 1, if this is a 1 over here, and then this is a 1, we have 2, right? 1 plus 1 is 2. What has to be next? What can we add to 2 to get to 12? Right, we need to add 10 to 2 to get to 12, but we need to split that 10 in half because we have 2 sides, right? So if we split 10 in half, we'll have what? Yes, 5 plus 5. So 1 plus 5 plus 1 plus 5. In other words, 6 plus 6, that's going to give us a perimeter of 12. So that one checks out. What if we do 2? Can we do 2 on the side? Let's try it. If we have 2 units here, again, that's going to mean that we're going to have 2 units over here. So we have 2 plus 2, which gives us what? Right, that makes 4. So now, what can we add to 4 to get to 12? Exactly, we need to add 8. However, we need to split that 8 into 2 because we have 2 sides to fill. So, here we have 2, 2, 4, and this is 4, and this is 4, right? So if I add 4 here and 4 here, we'll have 4 plus 4 is 8, plus 4 is, yes, 12. Sorry about all my dinging. Look at that. Okay, is there a way to do 3? I don't know. Let's try it. Let's try it. Okay, so if I have 3 down here, and I'm going to have 3 on this side. What's 3 plus 3? Say it out loud. Yeah, 3 plus 3 is 6. What can I add to 6 to get to 12? See, now you're just on a roll. You're like a little snowball picking up more snow as you go down the hill. Beautiful. So we need to add 6 to this 6. But again, we have to split it, right? Because we got to split that 6 2 ways. 3 plus 3. 3, 6, 9. It all works out. So we could go down to 4. However, we've done 4 already. So because we've already had that configuration, it would just be turned on its side. We're not going to do that one. Do you think there's a way to be 5? Oh, we've already done that one too. Do you think we can do 6? I don't think so. And I'm going to tell you why. Because this length is already 5, and this is 1, right? We can't get smaller than 1. So if we go if we have 6 this way, we have to have something here. And on the other side, this would be 6, and we'd already have 12, and we don't have any ends. That's not going to work, right? So I think we've found all that we can find. So let us estimate to draw our rectangles below and label the side lengths. So here, let me put this down here so we can kind of see both at the same time. So first I'm going to do this long feller. So over here I have 1 unit. Down here I have 5 units. There's that one. How about this one? I'm going to have 2 units on this side and 4 units on top. Oops. And then we have our square, which is our last one. 3 by 3 by 3 by 3. 3 units. Ooh. And 3 units. Awesome. Okay, let's explain our strategy for finding rectangles with a perimeter of 12. What was your strategy? What was our strategy? I didn't really think I had a strategy. I started with 1, and then I moved up from there and figured it out. So let's, I guess, explain that. I started with a side length of 1. From there, I knew the parallel, remember this? The parallel side must also have a length of 1. From there, I figured out what I needed, to add to 2, oh my goodness, add to 2 to get 12. It was 10. Next, I divided 10 by 2 in order, I'm going to say 2 again, too many 2s, in order to figure out the remaining 2 side lengths. Okay, I'm going to read that again and make sure that makes sense because that was a lot of writing. I started with a side length of 1. From there, I knew the parallel side must also be 1, right? This is the parallel side. These 2 are parallel. From there, I knew the parallel side must also have a length of 1. From there, I figured out what I needed to add to 2, because I had 1 over here and 1 over here, which is 2, to get what I needed to add to 2 to get 12. It was 10. Next, I divided 10 by 2 in order to figure out the remaining 2 side lengths. That makes sense in my mind. If this is a mumble jumble of mumbledness, then don't write it. If this doesn't make sense to you, you need to put it in your own words, okay? But if that makes sense to you, if you're like, oh, okay, I got you, Mrs. Brady, I'm picking up what you're putting down, then write that, okay? And if you need more time, just pause and copy what I've written. All right, let us read C together. It says, find the areas of all the rectangles in part A above. Okay, so what I'm going to do is I'm going to label these rectangles. I'm going to do A for the 1 by 5. I'm going to do B for the 2 by 4 and C for the 3 by 3 so that it's easier so we know which one we're talking about. So the area of A equals, we're going to multiply, right? Oops. 1 times 5. It's the area model. So 1 times 5 equals 5 units. Can't forget that label. How about B? Let's do that. Area of B equals side length times side length. And 2 times 4 is, yes, 8 units. And the last one, area of C equals side length times side length equals 9. Awesome. Okay. Let's read this one together. Let's read D. It says, the perimeters of all the rectangles are the same. What do you notice about their areas? What do you notice? Are they the same? No, they are not. Do you know what I noticed? That this is kind of the opposite of perimeter. Remember yesterday when we were talking about perimeter, the bigger the difference in side lengths, right, the larger the perimeter. But in this case, the bigger the difference, the smaller the area. That's very interesting. So I'm going to say something very similar to what we said yesterday when we were talking about the relationship and perimeters. I'm going to say something similar, except having to do with area. I notice that as the difference in side lengths gets larger, the area, what in the world am I writing right there? The area, I'm trying to write the area in the same word. The area gets smaller. Beautiful. All right, let's flip a rooski. Okay, on to number 2. Please read with me. It says, use your square unit tiles or a piece of paper to build as many rectangles as you can with a perimeter of 14 units. Estimate to draw. So same strategy, different number. Okay. So I am going to use exactly the same way that I did over here. I'm going to do that again. So I'm going to start with a side length of 1. Okay. Here's my side length of 1. If that side's 1, this side must be 1 also. So now I have 1 plus 1 is 1 plus 1 is 2. So now what do I need to add to 2 to get to 14? Yes, I need to add 12. What can I divide? I need to divide 12 by 2 because I have 2 remaining side lengths. Here's one side length and here's another side length. I need to divide that 12 by 2 so that I have 2 even side lengths. I can't have a 7 up here and a 5 down here, even though those equal 12. That's not going to work, right? Whatever this side is, this side must be the same. So I divide 12 by 2 and I get, yes, 6. So 1 plus 1 plus 6 plus 6 equals 14. Yes. Okay, now let's go to 2. Let's do a side length of 2. This is 2. No. This is 2. So 2 plus 2 is, thank you, 4. What can I add to 4 to get to 14? Right, I need to add 10. However, I need to divide 10 by 2 because I have 2 remaining sides that I have to fill, and they must be the same. So 10 divided by 2 is, yes, 5 and 5. And what do you know? 2 plus 2 is 4. 5 plus 5 is 10. 4 plus 10 is beautiful. 5. Okay. How about a 3? 3. 3. All right. I apologize for that. Okay. So 3 plus 3 is? Yes. 3 plus 3 is 6. What can we add to 6 to get to 14? It's not another 6, because that would be 12. You have to add 2 to that 6. Yes, it's 8. So we need to add 8 to this 6 in order to get a perimeter of 14. However, we have to divide that by 2 because we have 2 remaining sides and they must be the same side length. So 8 divided by 2 is 4. Yes, beautiful. 4 plus 4. We have 4 up here. We have 4 down here. And if we add these two together, that's 7, and we know that 7 plus 7 is 14. It checks out. Beautiful. Okay, so we did 1, 2, and 3. If you'll notice, similarly to over on this side, we've already done 4, right? We have a side length of 4. We would just need to turn it for it to be exactly to follow our same path, but that's not necessary. We also have a side length of 5. We have a side length of 6. Can we do a side length of 7? No. Very similar to why we can't have a side length of 6 for a perimeter of 12, right? If I have one side length of 7, that must mean I have another side length of 7. And 7 plus 7 is 14. I have nowhere to go on the sides, right? So that's it. That's all we have. That's all she wrote for that one. Let me put this, I'm just going to fold this so that it's easier to see. It's not all up in my groove. Okay, just going to put that there. And let's draw to estimate. It says estimate to draw. So draw to estimate, estimate to draw our 3 rectangles. These on this side. Cover this with my hand. Okay, and then it says label the side lengths. So we have 1 unit here, and then 6 for our long side units. I guess I could label all of them. 1 unit, 6 units. And then we have this one, which is 2 units. We have a 5 on top. Two on the other side, and 5 on the bottom. And our last little feller, 3 and 4. Just put that under here so we can still see both. Okay, so this side is 3 units. 4, I know this one's bigger than that one. This is why we estimate. And it doesn't say, you must be perfect. It's impossible. Okay. Now, just like we did on the other side, it says, find the areas of all the rectangles in part A above. So again, I'm going to label these. I'm going to give them letters. We already did A, B, C. So I'm going to start with D, E, and F. And let's find the areas. Go. So let's find area of D equals side length times side length. So 1 times 6. 6 equals 6 units. Square units. Awesome. And area of E equals side length times side length equals 2 times 5 is 10 square units. What do you notice about those areas? They're getting larger, aren't they? And lastly, area of F equals side length times side length equals 3 times 4 is, yes, 12 square units. Which reminds me that I didn't do that on this side. I didn't put square units, so I'm just going to slip that in there. Here. Okay, sorry, my computer fell asleep. All right. Now, let's read the last one. It says, please read with me. Given a rectangle's perimeter, what other information do you need to know about the rectangle to find its area? What information do we need to find the area of a rectangle? Let's look at our examples. So if we have a rectangle and it says the perimeter equals 14, what do we need to know? Can we find the area just from that? No, because all of these have the same perimeter, but look at their areas. This area is twice as much as this one. So perimeter is not going to give us a whole lot of help as far as finding the area. So what do we need to know to find the area? Say it out loud. Yes, we need to know the side lengths. So let's say it. Let's say we also need to know the rectangles. Please notice how I'm spelling rectangle, and then I'm doing this, which is showing its possession, because the area, the rectangle's side length is what we need to know. Those side lengths belong to that rectangle. They are not ours. They are not my coffees. They belong to the rectangle, and only that rectangle. Okay. We also need to know the rectangle's side lengths in order to find its area. Ooh, 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 ooh. My friends, you have finished all of third grade math. Can you even believe it? So proud of you. I wish that I could celebrate with you in person, but to keep us all safe, that is not possible. But I want you to know that I'm proud of you. Great job. I miss you, and I'm looking forward to seeing you in the fall. Bye-bye.